Hello friends, myself Bhushan Inje. My topic of discussion is combination logic circuit. These are the content that we are going to discuss in today's presentation. What is combination circuit? When the logic gates are connected together to produce specified output for a certain specified input variables with no storage involved, the resulting circuit is called combination circuit. The very important point to be noted here that storage. In combinational logic circuits, we don't find a storage requirement. This is what a block diagram of combinational logic circuit. In that, we can observe that the number of n input variables is given as a input to the one side and will obtain m output variables. This is what a procedure to determine Boolean functions for output of circuits from the given scenario. The first step is that make sure that a given circuit is combination circuit, not a sequential circuit. The combination circuit has a logic gates with no feedback path or the memory element. As we are talking about, the combination circuit don't require a storage. So here we can easily get identified that the given circuit is a combinational one if it don't find a storage. Label all the gates output that are function of input variables with arbitrary symbols and determine Boolean functions for each gate output. Then step 3, label the gates that are a function of input variables and previously labeled gate determine the Boolean functions for them. Step 4, repeat step 3 until Boolean functions for output of the circuit are obtained. Step 5, finally substituting previously defined Boolean functions, obtain the output Boolean functions in the term of input variables. Let's see this with the example. We have step 1 in that this is a example that a circuit with various basic logic gates, and these are the input to the circuit A, B, C. The three variables are given as an input to the circuit and its variations. We use basic gates like AND, NOT, OR, and these are the two functions that we obtained as an output to the combination circuit. Let's say the first step, make sure that the given circuit is a combination circuit. So here we can conclude that this circuit is a combination circuit because we don't find any feedback path or the memory device is enabled. Second thing, label all the gates output that are the function of the input variables with arbitrary symbols and determine the Boolean functions for each gate output. So here we have define this A, B, C is the input variable in this case. Just like that, in case of the output of this, let's say the output of this one we can use as a Y1. This is Y2. This is Y3 and this is Y4. These are the output of the various gates. Let's say this is Y5, output of your X. Now the Y1 is nothing but A and B and C. Just like that, the output of Y2 is B complement, then C and. Okay, then we have output of Y3. Let's say it is A or B, and here Y4 is C or B. Okay, just like that we can have this step number 3. Repeat the step. The label gates that are a function of the input variables and previously labeled gate and determine the Boolean functions for them. So we can do these things for further until we'll finish the all the logic gates produce an output. Here complement of Y1 is the output of your NOT. Now this Y bar is given as an input, one of the input to the OR, and the another input to the AND is Y2. So the output of, let's say it is a 6, so the output of this XOR OR is nothing but Y1 bar plus Y2. Just like that, this is your 7, let's say Y7. This gives you Y3 plus Y4. Here we have Y8 gives you output as a B inverter. Finally, we'll be obtaining. Here we separately given that the B is the input variable. So Y6 into B is the output of this F1, a function F1, and a Boolean function F2, obtaining B bar into Y7. This is what the solution of this the previous circuit diagram, and you will be obtaining that similar to this answer. So just like that we follow this all the procedure and we'll obtain the Boolean functions for them. Here we can note down where we can simplify this Boolean function for getting to design a combination circuit for them. Once the function of the output circuit is known, we can easily determine the truth table using following steps. Step 1. Determine the number of input variables in a circuit. For n inputs, list the binary numbers 0 to 2 raised to n minus 1 in a table. Determine the output of the selected gates for all the input combinations. Step 3. Obtain the truth table for the output of those gates that are the function of previously defined values. step 4, repeat step 3 until you get truth table. This is the truth table of the previous example. So in the previous example, there are total 3 number of variables that we have, A, B, C, and the number of output that we get obtained there, that number of 8 output variables that we need to specify here. Let's say one big relation that the 2 raised to n equals to m. In a combination logic circuit, you give input as 2 raised to n, will be obtaining m is the output. So in this case, we can say that the 3 number of inputs are there. 2 raised to 3, it gives you 8 output. So we'll be obtaining the 8 output there. So that's why y1 to y8 will occupy that, the represent 8 number of outputs. F1 and F2 will obtaining the Boolean functions from the said circuit that we previously discussed. When your ABC is a 0, 0, 0, so y1, y2, y3 up to y8 is representing the value 0, 0. Just like that. Now the next design procedure is the design procedure of combination circuit. Start from the outline of problem statement and end the logic diagram, or the set the Boolean functions for which the logic diagram can be easily obtained. The design procedure of the combination circuit involves the following steps. The problem definition. Determine of number of variables. Available inputs variables are required input and output variables. Assigning letter symbols to input and output variables. The derivation of truth table indicating the relationship between input and output variables. Obtain simplified Boolean expressions for each output. Obtain the logic diagram. This is what we have in a previous slide in a diagram representation. Let's have an example. A combination logic circuit with a 3 input variable that will produce a logic 1 output when more than one input variable is 1. So let's say the 3 input variables, so number of 8 possible representation is there. 2 raised to 3, it gives you 8 possible combinations. So combination 1, this is what 0th position, 0. So 0, 0, 0. We don't have truth table. It is represent 0 because of the said statement is false. Here it is true because see that will produce logic 1 output when more than one variables are 1, logic 1. So here it is also false. So in this 3 case it is false. Then we have 0, 1, 1. In that case more than one is 1 is found in the input variable combination, so it will produce 1. Just like that we built the truth table from the derived problem statement. This is another example to define the problem statement is that